Hello, hi guys, good afternoon. Yeah. In this lecture, we have discussed expression for variation principle. In last lecture, we have discussed variation method or variation principle statement for variation method. Okay, now we will discuss expression. Suppose, suppose a particle is in one dimension box. Since the potential outside the box is infinite, okay, the potential of the box outside of the box is infinite and the potential inside the box is zero, because then the probe of finding particle outside then the probe of finding particle outside the box is zero and inside is maximum the probe. Okay, now consider a box having length L. Okay, then the first equation is like that, trial is equal to 0, trial outside for is equal to 0. That's the equation 1 phi. If phi is no is normalized, there are two types in this variation method. If two conditions are there, if phi is normalized, other one, second condition is if phi is not normalized. Okay, now we will discuss if phi is normalized. At that time, length of the box varies from 0 to L. Okay, length of the box varies from 0 to L. Consider a particle x lies in between 0 to L. The particle x lies in between 0 to L, in between 0 to L. Okay, that is x, sorry, that's is 0, 0 is less than equal to x is less than equal to L. Okay, now we know that, as as uh, as we know that, the H Hamiltonian operator is equal to minus h cross square upon twice m into d square by dx square. This is equation number 2. Now second equation, 2a, is expectation of Hamiltonian operator is greater than equals to E, that 2a, the equation number 2a. Since the particle is 0 less than equal to x is less than equal to L, then its equation will be x into L minus x. This is equation number 3. Okay, x is the particle. Now, using equation 2a and 2, in last page we have discussed equation number 2, Hamiltonian H is equal to minus h square upon twice m into d square by dx square. This is equation number 2. So at that time, we will put the values of equation 2a for 2. Integration of x into L minus x into minus h cross square upon twice m into d square upon dx square. This is double derivative into x into L minus x into derivative dv. Okay, now in next term, minus h cross square upon twice m, we have taken one side because this is a constant term. This is constant term, so that's why in next term we have shifted to this side. At that time, minus h cross square upon twice m integration of x into L minus x square, x L, x into L, xl, again x minus x into minus x, that is minus x square. So now the second d square by dx square, as this term is as it is. Now xl minus x square into dv, this term x multiplied by this term. Okay, now in next term, as like a constant term is as it is, then integration of xl minus x square. At that time we should have to derivative, double derivative, solve this term at first. In this term we have to solve d by dx into L minus twice x x square. The derivative of x square is minus twice x into dv. Okay, now in this term, minus h cross square upon twice m into integration of xl minus x square into minus 2 as it is into dv, derivative of this term, that is minus 2. At that time, now in this term 2, that is it, it is in divided by, so 2 by 2 it get cancel, and minus into minus, this is also cancel. Okay, now next term, h cross square upon m integration of xl minus x square into dv, this term. Okay, now we should have to solve the integration, this integration, h cross square upon m into lx square upon 2 minus x cube upon 3, the integration of 0 to L. Okay, this is equation. Now in next term, h cross square upon m, we know that x as a L, put x is equal to L, then L into L square upon 2 minus L cube upon L cube upon 3. In next term, h cross square upon m, L cube upon 2 minus L cube upon 3. That is the equation. The equation will be h cos square upon m into L cube. L cube take as a constant and 2 multiplied by 3, that is 6. Okay, 2 into 3. Then in next, the equation 4 will be L cube, when we shift that term as like a cross multiplication, it's L cube into h cross cube upon 6m is greater than equals to E. E is nothing but the energy of a particle. This is the required equation when phi is normalized of a particle. Okay, now we will discuss for now the second one we will discuss for expectation of phi if phi is not generalized. Okay, at that time we should solve the example, we should solve the equation, that is integration of x into L minus x into L minus x derivative, okay, is equal to integration of xl minus x square, then xl minus x square derivative. Now integration of x square into L square minus x cube L minus x cube L plus x to the power 4 derivative. So in next term we solve as like integration of x square into L square minus twice x cube, okay, twice x cube L plus x to the power 4 derivative. And now next term x cube upon 3, okay, we will solve the equation. At that time when we solve the equation, x cube upon 3 into L square minus twice x to the power 4 upon 4 L into x cube x to the power 5 upon 5 integration of 0 to L. After solving the integration and the derivative, okay, the equation will be L to the power 5 upon 3 minus L to the power 5 upon 2 plus L to the power 5 upon 5. After cross multiplication or minus plus signs changes, 1 into L to the power 5 minus 15 into L to the power 5 plus 6 into L to the power 5, then divided by 3 into 2 6, 6 into 5 30, that's equal to L to the power 5 upon 30. We know that variation principle, using variation principle, expectation of Hamiltonian operator upon expectation of phi, get phi, is greater than equals to E. At that time just put the values of expression. Okay, we know that the expectation value of Hamiltonian operator is L cube upon L cube into h cross square upon 6m, and we also know that when phi is not generalized, at that time the equation is L to the power 5 upon 30. So we will insert here all the values of these two expression, Hamiltonian H, expectation of Hamiltonian H and expectation of phi values. After solving this, L cube upon L cube upon h cross square upon 6m upon L cube upon 30. After solving this, we will get L cube into h cross square upon 6m into 30 upon L by 5, that is greater than equals to E. After this, the final equation will be, after solving the equation this, we will get the term 5 h cross square upon m into L square is greater than equal to E. This is the equation for, this is the expression for variation principle or in one dimensional. Okay, so in this lecture we have discussed expressions for variation principle. In next lecture we will discuss about WKB approximation. Okay, if you like this video, you can share, and please share to needful person, and thank you.